Hello, hello. This is our last video for chapter 7 through 10. Thank goodness. Thank you for hanging in there with me. So this one is going to be on bond energy. And again, we are going to be calculating enthalpy. Now, we have done a lot of this already in terms of different ways that we have calculated delta H. We have done Q equals MC delta T. We have done product minus reactants with the heat of formation values. We have done Hess's law. And now we have another way to do it. So it's really just going to be looking at the information that they give us in which way that we were going to do it. So if we think about an equation, I would hope that you think about with our reactants that we need to somehow break the bonds in our reactants, get them to rearrange, and then go to our arrow and form some bonds that we're going to release some energy. So we're going to break some bonds as a reactant, which is going to be endothermic. We're going to take that energy in, and then our bonds are formed through releasing of energy. Okay. So the first thing is we need to do pay attention on page 351. You're going to see that on there is a chart of all kinds of these values that I have down here. The other thing that you're going to see is that they have drawn out these structures for you for the most part. And so they are there. It is something that AP will do the same. Sometimes they even draw all the structures and you just have to apply it. So it just really depends how the question is written. So in this one, we are going to try to figure out what the enthalpy is of nitrogen gas plus hydrogen gas making some ammonia. And so you can see that I wrote that nitrogen and hydrogen are diatomic, and then I went through and I balanced this. And again, reiterating what I just said, our reactants are going to be breaking bonds and our products are going to be forming bonds. So over here, we are going to learn more about this when we get to this graph over here. When we get to kinetics and we talked about activation energy, which is this part right here that we have to overcome in order for our reaction to work. But what we want to do right now is just focus on that I can measure the amount of energy that the reactants have. I can measure the amount of energy that the products have. You can see that the products have less energy than the reactants, so that means that energy was given off. So we do need to prove that this is exothermic, and we can calculate all these values. So if I go to page 351, you're going to see that the amount of energy, whether it's breaking the bond of a triple bond of nitrogen or forming it, it doesn't matter if the energy is going in or leaving, it's going to be the same. And so I have that it says that it's 941 kilojoules per mole. And then you can see that, again, we know that this half of the reaction is bonds are breaking, so it's endothermic. Notice that I have a positive sign here for these values. And then I have 3H2, so that means it's 3 hydrogen bonded to another hydrogen, and each one of them is 432 kilojoules per mole. Again, I'm getting this from page 351 in our text. And then on the other side, we are forming 2 moles of ammonia. So I have both of them drawn, and you can see that I have 6. What is the 6 representing? It's going to be 6 nitrogen to hydrogen bonds. So as I go around and count 1, 2, 3, 4, 5, 6, I have 6 of them. I look up what the value is. I put the negative in front of that because I know it is on my product side and it's going to be releasing that energy. And then I just go ahead and add the left side to the right side, as you can see here in my final calculation, and indeed it is an exothermic reaction. Okay, so if we look below and we stay on that same page, I am calculating the combustion of methane. Now this one I just wrote in words, and then you would have to write and balance the equation, and you'd have to write all the structures below it. For the most part, AP is going to have more of this done for you. You just need to understand how to use the chart and the values. So I can see that from methane that I have 4 carbon to hydrogen bonds, which I can see down here. I have 2 moles of oxygen, which when it's O2, it has a double bond, and you can see that I wrote that there. And then I have carbon dioxide that has a carbon to oxygen bond on one side and another carbon to oxygen bond on the other side. This does have a starred value, I believe. I don't have the chart open in front of me, but you have to make sure you're looking at the starred value to get that value for carbon dioxide. And then I have 2 moles of water. Keep in mind that when I draw my molecules out, I have OH bonds. How many of those do I have? I have 4 of those. So again, if you look at my values, everything on the chart is positive. So where did I get these negative values from? And that is because I am on the product side. It's an exothermic reaction. And so I put the negatives in front of it. And then go ahead and do all of your algebra and your math on that. And you can see that this is indeed, again, another exothermic reaction, which should make sense to you. If you are burning something, you have combustion going on, that you are releasing energy. And we did indeed prove that. So I think with a little bit of practice, it's not going to take much on this, just because I think that you guys have a good handle of all of these things here. So I do have 3 problems here. I will have all those answers posted. If you want to practice, I think you should practice a little bit just to make sure that you have this too. All right, well, I hope you guys are doing well, and we only have a few more days left in class together, but we can do this. You take care.